Hey friends, Dr. Borole is here. Today we are going to focus on mobile communication. It is also called as cellular system communication. Cellular system communications are the new generation communication system. We have seen earlier the radio system used for transmission and reception of the signals and the communication information. In radio systems, we have seen that there is a large antenna installed at the center of the area with a high power transmitter which will radiate large amount of power to cover wide area of reception. Whereas in cellular systems or mobile communication system, there are multiple small towers and antennas are used to radiate the power over smaller area called cells, and multiple cells are used to cover the total area of reception. Whereas in the older approach of communication where a single large antenna is used, there are some limitation of that system. In conventional systems of radio communication, the first major limitation is the frequency reuse was not possible. The subscriber capacity expansion with the same spectrum is not possible because in conventional radio systems, all the information is radiated with a particular frequency band. Whereas in mobile communication system, these advantages are taken care by dividing the total area of reception in smaller areas called cells. So therefore, in cellular systems, it is noted here that the reception area or say city area is split into cells. And in every cell, there is a single power transmitter at the center, which is mostly omnidirectional. That is radiating the power in all the directions. But since the power used for transmission is less, the area coverage is less. The cell size is around 10 square kilometer for low subscriber density. So it can be 3 to 4 square kilometer for high subscriber density. When subscriber density needs to be increased, the cell size has to be reduced. The total area of the coverage can be mapped by using cells and the multiple cell clusters. Cluster is basically a group of cells. So with the group of cells, the area can be mapped. We can see shortly how it can be done. The coverage area of the cell is governed by the transmitted power and number of users. A large cell is replaced by many low power transmitter. Those are small cell as shown in figure. In earlier days, a single large power transmitter is installed at the center of the area of reception and it radiates in all the direction. So therefore, basic shape of the cell is circular, whereas circular cells are not suitable for mapping purpose. Therefore, in cellular communication, the shape of the cell is decided to be a hexagonal shape. Other shapes are also tried, but hexagonal shape for estimation purpose is most popular. So, in the older communication systems, the single cell of reception can be eliminated and replaced by a smaller cells having a low power transmitter at the center, and it radiates in the area called cell. Whereas group of cells arranged shown in this figure is called as a cluster, and such multiple clusters are used to connect and map the total area. Each cell consists of its own transmission system and its controller at the center, so that the information can be radiated over the cell area. In mobile communication, either transmitter or receiver or both can be movable. Whereas in conventional communication system, mostly the transmitter and receivers are fixed at some locations. So difference compared to general communication system and mobile communication system is that in mobile communication, the transmitter can be stationary and receiver can be movable, or transmitter as well as receiver both can be movable, and that's why it is called as mobile system. This mobile communication is always a wireless communication, and the channel is a air channel. Why so? Because the communication system devices are mobile in nature. They are both movable, and that's why only media available is air. Wired media is not suitable for this communication, and therefore only wireless communication is used for communication systems used in mobile communication. A typical mobile communication system is standardized by the standard called GSM standard. GSM stands for Global System of Mobiles. GSM uses FDMA, that is called Frequency Division Multiple Access, for its analog communication, whereas digital communications standard of GSM use TDMA, Time Division Multiple Access approach, for GSM connectivity. We have seen FDMA and TDMA earlier in modulation techniques. The mobile phone network structure along with the public switch telephone network PSTN is shown in following figure. PSTN is a public switch telephone network system like landline communication system. So in this figure, we have seen various landline phones are connected to a PSTN network via a telephone office and its equipment. Telephone office equipped with a switching center, and this switching center is also connected to our mobile system base stations. Base station is called as a station which is situated at the center of every cell. These base stations are connected to PSTN networks. So this way, when the telephone network is to be activated from the mobile communication system, the base station cell towers get connected via a PSTN switching center to landline phone. A typical area map with multiple clusters are shown in figure 2. Here we will see the hexagonal shape cells. Instead of circular shapes, hexagonal shapes are shown. Here all blue color cells are shown, and around that the cell F2, F3, F4, F5, F6 and F7 are shown. So the cell from F1 to F7 forms a cluster of cells, and multiple clusters of cells are connected to each other to map the entire area of reception. The distance between the center cells two adjacent center cell is called as reuse distance. So in this mobile communication approach, we can use same frequency channel for transmission between the adjacent cell F1 and this second F1 and third F1 and say this fourth F1 cell. Whereas since they are separated from each other by a significant distance, there is no interference of the channel frequencies used from one cell to another. Reason being, the area of reception is limited to that cell and there is a safe buffer distance between the two. When the cells are very close to each other or even connected to each other, there is a inter-channel interference because the radiation overlaps, and if same channel is used for transmission of the information, then there is a interference and there is a disturbance in communication, and therefore there is sufficiently large reuse distance can be provided between the cells, and therefore hexagonal cell with cluster is providing sufficient large distance, and therefore hexagonal cells are very popular for estimation of reception of mobile communication signals. Every cell in this area mapped by the clusters have its own omnidirectional transmitter at the center, and which covers the area of the cell, whereas this transmitter at the center is also called as base station of the cell. So here the diagram shown with the color cells indicates the same thing. Here every cell is shown with its own base station and they are radiating in their area, whereas adjacent cell have different channel frequencies, so therefore they are not interfering each other. To maintain the shape of a cell in hexagonal fashion, normally the multiple radiating antennas can also be used at various corners so that the area can be mapped like a hexagonal area of transmission. And cells these cells have these multiple antennas, they are radiating inside the area of the cell. This figure shows the base stations with six distributed antennas. The main antenna is called base station and the distributed six antennas are shown. The another diagram is shown here where the cells are shown circular and the total cluster of 7 cells is shown. So here we will note that between these circle receptions in this area particularly, there is no signal available, and therefore in circular shells there is a dead areas where no mobile signal is available, and therefore circular areas are not used for mapping the mobile communication because of these dead zones. If we are using the overlapping areas of a circular shell, then there is a cross-channel cell interference and therefore signal will be lost in that area also. And therefore, the hexagonal shaped cells are most commonly used. Some of the important points about the cellular system are discussed here. The first thing is mobile communication systems are using the hexagonal shaped cells as shown in the above figure. Each cell has its own base station situated at the center. It's also denoted in the literature by letter B S. The base station is to act as interface between the mobile station and the cellular radio system. The mobile station is denoted by the symbol MS, and mobile station is nothing but our convention mobile handset. The cellular radio system is nothing but the transmission and reception antenna system with their controllers. All base stations of the cells are connected to the mobile switching center. See, we have seen in the PSTN approach, all of these central base stations, they are connected to a bigger mobile switching center, also denoted in literature by MSC, mobile switching center. The communication between these stations is bidirectional. Say between MSC and the base station BS, the communication is bidirectional. They can talk to each other in bidirectional way. For that purpose, they are using different channels allocated over the bandwidth offered to that area station. The channels are divided in two groups: forward communication channel called FCC and reverse communication channel called RCC. These are the control channels. And the third group of channel is voice and data channel. So, if the area of reception is allocated the frequency band of say around 900 megahertz, then this band is divided in number of channels, and these audio channels or data channels are divided in the said groups FCC, RCC and voice and data channels. Voice and data channels normally carries the information like audio and data, whereas FCC and RCC are the group of channel they are used for control information transmission from base station to master control station. Base station communication with master station is on forward communication channel, and master communication center or master switching center communication to the base station is on the reverse communication channels. Whereas if there are 200 channels available, out of that around 80% channels are the voice and data channels, and 20% channels are allocated to the control channels. Since control information is not regularly required, that is required during the start of communication and end of communication. So therefore, number of control channels required are less. The another system called NSS, Network and Switching System, that includes the mobile switching center MSC, and it acts as an interface between the public switching telephone networks PSTN and the cellular base stations. So MSC is basically a part of NSS. NSS have other sub blocks also we will see shortly. And via MSC, the network system connects the telephone network to the base stations, and base stations are connected via wireless communication channel to the mobile stations. Mobile stations are your handsets. This NSS and MSC provides the supervision and control operation in mobile communication systems. Communication can take place between two mobile subscribers. They can be stationary or they both can be movable. The movable subscriber and the landline telephone can be one example. Whereas the two mobile communication both are moving is the another example. So in mobile system, the communication stations, that is mobile station, are mostly moving, and mobile stations can even move from one cell to another. When the mobile device crosses the area of one cell, they enter in the another cell. And mobile communication standard GSM recognize it and manage it to keep the communication live even though the cell is traversed by the mobile device. Normally, to get the communication started, every mobile station, that is your mobile phone, continuously hunting and get connected to the base station of that area in which it is lying. Means it is connected to the base station of the cell in which the mobile phone is. And it is always hunting and getting connected to the sales base station. So even though you are not doing any call and your mobile device is idle, it is always connected and informed with the base station of the cell in which currently it is lying. If the mobile subscriber travels from one cell area to other, then the mobile station gets automatically connected to the base station of that cell. Thus, the service provided to the mobile subscriber is continuous without any break. Since the mobile device, that is mobile station, is having capability to get connected to the base station automatically to the new cell, and base station also have this capability to acknowledge the new device entering in its area of reception. The mobile communication is evolved from first generation, say 1G, to currently we are in fifth generation GSM systems. In first generation, mostly the mobile communication systems were analog in nature and they were using FDMA approach for transmission and multiplexing multiple channels. They are mostly using FM signals for communication. In second generation cellular systems, the digital approach of communication was introduced and all the system becomes digital communication systems, and they are mostly using CDMA and TDMA multiplexing techniques. Two most widely used 2G systems are the GSM system, the global system of mobiles, and IS-95 systems. Now we will discuss about global system of mobiles, say GSM. GSM is the standard that is developed by European Telecommunication Standard Institute. It describes the protocol for second generation digital cellular networks used by mobile devices such as mobile phone and tablets for communication. Various digital mobile systems developed over the year are: first, GSM system, that is global system for mobiles and very commonly used over the entire world. Around 70% systems and over the entire world for communications are the GSM systems. Another is North America NATDMA system. NA for North America TDMA system, time division multiple access system. Another is the CDMA system, that is called code division multiple access system. PDC systems for digital mobile communication. Those are personal digital cellular systems. Whereas GSM is used over 70% of the area of the world. The multiple access is a method that allows the multiple transmitter to send the information simultaneously over single communication channel. In analog cellular systems, the multiple access techniques called FDMA, frequency deviation multiple access is used. But now we are in the fifth generation. We are using 4G and 5G. So analog cellular systems are mostly obsolete. Currently, we are only using the digital communication systems. So digital GSM systems, and where TDMA and CDMA are used for accessing the communicating devices. The GSM system was first implemented in Germany in 1992 and it was named as D2. The GSM is a 2G cellular system standard developed in order to solve the fragmentation problem of first generation GSM. Further development till date, we reach to 5G and the development of 6G communication systems are going on. TDMA or CDMA uses digital modulation techniques. A typical GSM architecture is shown in the following figure. See the block diagram. Here, in the block diagram, at the center of the system, there is NSS, Network Switching Station. This network switching station is further connected to a telephone network system or other GSM system base stations. Here it is shown NSS is connected to the base station BSS of the cell. The BSS is connected to the mobile station. Mobile station is nothing but your mobile phone. And BSS is that transmitter and its control system at the center of the cell. This BSS is also connected to OSS, that is operating station systems. You will see that between mobile device and the base station, the communication is bidirectional and it is over two types of channels. The one channel is voice and data channel and another is the control channel that is shown by the dotted line. Whereas communication between BSS and network switching center station is also bidirectional over data and control channels. Whereas the communication with OSS and BSS is on control channels only because OSS is normally provide control for the BS stations. So various component subsystems of GSM architecture is listed here. We have seen from the block diagram there is a mobile station MS and that is nothing but our mobile phone. The base station system that is situated at the center of the cell and denoted by BSS. BSS have two blocks. The transmission station, that is antenna transceivers, and the tower. And the control system, base station control system called BSC, base station controller. So base station system have two parts, BTS and BSC. At the center, there is network and switching subsystems called NSS. The NSS is connected to cell BSS and it is also connected to the PSTN network system. Whereas PSTN network system is nothing but the control station of your local telephone network system. PSTN stands for Public Switch Telephone Network System. Whereas NSS is also connected to OSS, that is operating subsystems, and various BSS. Here two BSS are shown. But this NSS can be connected to the VSS of multiple cells. Those are the base stations. NSS consists of various building blocks. One is Mobile Switching Service Center, MSC. Second is it is maintaining the databases like Home Location Register, HLR. Second database the NSC maintain is the Visitor Location Register called VLR. Third database the NSS is maintaining is EIR, that is Equipment Identity Register. Fourth database it maintains is Authentication Center, AUC database. NSS provides the flow management and call processing for the mobile devices, moving between various base stations. A typical map of a mobile communication system is shown here. You will see these are the mobile stations. Those are mobiles equipped with SIM cards. The base station is shown here. The base station consists of the transceiver system and its control station. And the network subsystem can be a PSTN network that can be connected to a telephone line or that can be connected to a wireless telephone network. The blocks shown in this figure are the mobile stations. Those are the cell phone, probably with display, a DSP processor, a radio receiver regulatory system by SIM cards. The base station system BSS, each network cell has its own BSS at the center, that is transmission station and its control station. What are the functions of BSS? BSS serves as the connection between network subsystem NSS and MS. So here in this diagram, this network subsystem is connected to the mobile station block via the base station, this intermediate block. BSS has two parts we have already discussed, the base transceiver station and the base station controller as shown here. See, this is base transceiver transmitting antenna and the transmitter, and it is controlled through a controller station. The base transceiver station BTS consists of tower, transceiver and antenna. Based on the cell's consumer density, every BTS includes from 1 to 16 transceivers. The base station controller BSC manages the first thing, radio resources for BTS. Second, the radio channel configurations and handovers between the stations and various blocks. The links between MS and MSC is managed by base station controller. That is communication between the mobile handset and the mobile switching center. The base control station is responsible for inter-cell handover. Now, now what is handover? Handover is nothing but the handshaking signal transmission between the two devices, that is mobile station and mobile switching center. So, base station controller manages these handshakes and handovers. It also allocates and emits mobile station, frequency bands, and time slots. It manages inter-cell handover and transmit and control the BSS and MS radio power. So this handover is nothing but whenever the mobile device is moving from one cell to another, it enters in the area of another base station. So base station manages to connect the moving handset signal to the new signal, and that is done by doing some exchange of signals on control channels, and that can be managed and controlled by BSS. It also controls the power which will be received by the mobile station via radiating the power from base transceivers. The network system, the network switching system NSS manages the information flow and call processing for the mobile devices. Those are moving between the base station. Here a typical diagram of a NSS is shown. It consists of MSC at the center. This MSC is connected to the PSTN networks via wired or wireless communication systems. It also maintains four type of databases we have already discussed. Those are VLR, that is Visitor Location Register, Home Location Register, the Authentication Register, and Equipment Identity Registers. These are databases. Those keeps the record of your mobile handset, the mobile positions, and the authenticity of the mobile stations, and second, the authenticity and the equipment validity in various registers. So home location register, we will see the functions of these blocks and databases shortly. The operating subsystem OSS manages the network operation and maintenance, charging and billing systems of a mobile, subscriptions and subscribers. Management of mobile equipments can be done by operation subsystems. The modulation used by GSM system is Gaussian minimum shift key, that is GMSK. This is a digital communication technique. The block network switching system consists of following parts, and their job and responsibilities are discussed here. So first part of NSS is Mobile Service Switching Center. It supports the call switching across the cellular phones and other fixed or mobile network users. Means call can be connected between the two mobile phones, or one mobile phone and another landline phone, or between two fixed connections. The mobile cellular services like call registration, location updates, and call forwarding to the roaming user is provided by mobile switching center. Switching center is maintaining the log of the communication mobile station, and that's why every MSC have a record of a GSM coordinates of your mobile phone locations. The home location register HLR database This database is managed by NSS and it is about subscriptions. Subscription means whatever the mobile phone subscription you have taken from your mobile communication supplier like Airtel. So you are taking the subscription and its record is maintained by the NSS system. It also maintain the consumer last known position in home location register database. It keeps the record about the user after purchasing the subscription from the network operators. Means your total information about your address and personal information is maintained in home location register with your last working position of the mobile handset is recorded in home location registry database. Visitor location register database have various information recorded by NSS. It monitors the subscriber location within VLR jurisdiction. Means in the area of that network switching system where your device is located currently. So this location is always maintained in a database in the form of GSM coordinate. It determines whether the subscriber may access a particular service. It also keeps the record what subscriber have accessed. It keeps the record and allocates the roaming numbers during incoming calls. So when the mobile devices are moving around, then the roaming numbers allocation is a job and recording its information in VLR is a job of NSS. It deletes the record of inactive subscribers. The another database maintained by NSS is Equipment Identity Register, EIR. And EIR manages the network security mechanism. It stores the IMEI information about your mobile phone, that is International Mobile Equipment Identity. Every mobile station, say your mobile phone, have IMEI number and its record will be maintained in Equipment Identity Register in NSS. The categorizations of IMEI are as follow. The IMEI can be recorded in three lists by EIR database under the category of white list, black list, and gray list. White list IMEIs are the devices those are authorized and allowed for communication and they are recognized and marked by IMEI numbers. IMEI numbers are unique to every mobile station. Blacklist. The IMEI numbers of stolen or unauthorized devices are barred from accessing the mobile network by putting them in the blacklist. And therefore, once blacklisted, your handset cannot be able to use the GSM network. And this list is maintained in NSS, Equipment Identity Registers. So, as good as when your mobile is blacklisted, it is just a piece for playing games only and not suitable for communication purpose. The mobile IMEIs can be placed in the blacklist or removed from the blacklist by the network operators. as well as it can be requested by the user to blacklist your phone to the network operator, and they have a control of putting the phone in blacklist. Many a time this happens when our phone is getting stolen. A current generation phone have facility to communicate to the network operators, and you can, or subscriber can tell the network operator to blacklist that phone so that others should not use it. Gray list, it is an optional list, and the IMEIs, those are required further investigation, can be put in the gray list. And all these three lists are managed and controlled by Equipment Identity Register Database, that is managed under Network Switching Station NSS. Blocking of unauthorized devices is a job of EIR. Whenever the NSS connects the two mobile devices, it has the IMEI numbers of the mobile stations. So before making the connections, it checks this EIR database and check that the device is in which list. If it is in white list, it is allowed for communication. If it is in black list, then the communication is not allowed since the device is in blacklist. The identification of a stolen devices. For example, when the user reports the device as stolen, the IMEI is added to the blacklist on the request by subscriber to the network operator, and network operator can put it in the blacklist by requesting it to the NSS. Subsequently, when the stolen device tries to communicate to other device, its access will be denied by the network, and therefore the stolen devices are blocked. Prevention of the clone devices, for example, many a times the hackers can clone the device. So same device can be replicated. These clone devices are checked against the authenticity of their IMEI number. And if they found the duplicate IMI or cloned IMEI number, then they will block that device. Cloning involves basically copying the IMEI number from the legitimate devices to unauthorized one, whereas it can be caught by NSS by checking it in equipment identity registers. So equipment identity register database ensures only validity and unique IMEI numbers, those are allowed on the network. Provision of the information to the law enforcement can also be taken from equipment identity registers and above said four databases. Many a times we have seen the law enforcement agencies wants the data about a particular person or about the particular handsets. These data are available in these four databases. Those can be supplied to the law enforcement agencies by the network operators because they are managing the information in NSS. Dynamic updates can be provided by EIR. EIR database can be dynamically updated to reflect the changes in the status of your mobile devices. Addition and deletion of the devices to the blacklist can be possible because of the dynamic update facility, and this dynamic update facility is available with network operators. So network operator can on the request put the mobile phone on blacklist, or he can remove it from the blacklist on the request from the subscriber. Say for example, when your phone is getting stolen, you are immediately calling the network operator, say for example Airtel, and putting the request that this phone is stolen and please block it. So the IMEI numbers of the phone can be put in the blacklist because they have facility to enter this in the blacklist of NSS. So phone will be blocked from the communication and made useless. For example, whenever you get your phone back, then if you request again the network operator that you recovered your phone, then on request they can unblock it by removing it from the block list. So this is possible because EIR is dynamically updated and the update facilities are available via softwares from the network operators. The secure access is provided by NSS. The access to the EIR database is restricted and only authorized personnel can modify and retrieve the information, and these authorized persons are mostly the network operators like Airtel and Idea Systems, whoever is the network operator. They have the authority and authentication keys to manage the information in equipment identity register database. The authentication center AUC that offers the verification and encryption of the user identity and privacy of every call. So this is another database where whenever you communicate over your mobile phone to the another mobile phone, it is via NSS only. And the authentication database is maintained in NSS, which verifies before allowing you the access to the connection by verifying your identity via IMEI numbers, and once allowed, your communication over the channel between the two mobile subscriber is encrypted and that is managed by authentication register. The verification and validation key from the SIM card can be used for the purpose of verification. Our SIM card have a special 15-digit key. That key is used for verification of your subscription, and IMEI numbers and mobile identification numbers are used for verification of validity of your devices. And this can be done by querying the authentication center. To maintain the user's privacy and secure the user from other attacks, the key of the SIM card is also hidden from the user. We cannot see that key as a user. The operation and support system OSS is the another block of a GSM system network. OSS primarily manages GSM network and BSS traffic load. Means it manages the communication network requirements and the traffic load control between various base stations. What is traffic load? Traffic load means simultaneous connections of various mobile phone to other mobile phones. That is called as data traffic. So multiple mobile connections and data transmission load is also called as traffic load. As the number of base stations are increased due to customer population scaling, few maintenance duties are shifted to base transceiver station. That lowers the system financial responsibilities. The essential purpose of OSS, that is the support system, is to have network synopsis and assist the various service and maintenance organization with their routine maintenance tasks. A typical connection of GSM and GSM architecture is shown here. See, these base stations are basically the cell base stations. Various mobile handsets are connected to the base stations. One mobile set handset is shown here that is connected to BTS, whereas multiple handsets are connected to a BTS. BTS is basically the base transmission station, and multiple mobiles are connected via different frequency channels to these base stations. There are multiple cells and therefore there are multiple base stations in the GSM network that forms a cluster. These various base stations are connected to base station controllers. The base station controller basically handles the communication between BTS and BSC, and BSC to the operating support system as well as the MSC, that is in NSS. A second set of base stations and base station controller connected to MSC also shown here. So there are multiple. So there are multiple base stations depending on number of cells present in the entire area. There is one base station at least per cell. And to every base stations there are multiple mobile subscriber getting connected, and the connection is established by base station with the mobile switching center between mobile phone and the mobile switching center. Mobile switching center is further connected to a public switch telephone network. It can be connected to ISDN networks or it can be connected to the data networks. And via this network, it is getting connected to another MSC. And from another MSC, it is getting connected to the base stations of that MSC. And from base station, it can be connected to the mobile station and mobile handsets of the target devices. So this is in short the GSM architecture, and we have seen the block diagram of a GSM system which is functionality discussed in detail earlier. Somewhat more detailed block diagram is shown here. See here, every mobile phone is getting connected to a MSC via a base station, and base station have two parts. One is radiating station and other is the control station of that radiating station. Whereas one base station controller can control multiple base transmission stations. We have seen in one cells there are more radiating antennas. Up to 6 radiating antennas can be shown in the figure where we have studied the cells and how the cells are managed. And various mobile phone, those are lying in that cell. Cell means area. Those are connected via base station of that cell. So here you will see your mobile phone is getting connected via a cell base station tower and base station controller to the main mobile switching center. This mobile switching center manages these databases. We have already discussed in detail their functionality. Those are home location register, visitor location register, equipment identity register, and the authentication controller. These are managed in the NSS, that is network switching stations. And network switching station controls the communication via mobile switching center MSC with the database managed for authentication and validation of the communication. This network switching system is connected to other MSCs so that your target devices can be located in the other MSC areas. It can be connected to other networks also. So this is in short the GSM communication. Now, for example, how the call is established when you dial the mobile phone number. When you dial the mobile phone number, we already know that our devices are continuously hunting the carrier from the base station, and it is always in communication with the local base stations. When you dial the mobile number, It will send the information to the BTS with the number which you want to communicate, as well as it sends the identification number of the handset and the directory number. This will reaches to BTS and via base station controller. Base station controller or base station continuously do the handshake on the control channels with your mobile phones and get the data transmission between mobile phones and the base station can be controlled via the control channels from the base stations. Once your device is authenticated and allowed for the transmission, this will be verified by the base station by communicating your information to the mobile switching center. The mobile switching center finds your information in these registry databases. Those are your home location register. Whether your number and your target number is present in this register, that will be checked. First, the check will be the communicator's identification number, means whether you are present in that database. If not, then MSC will tell BSC that this number is not present. Then your communication will not be allowed. If your number is located in HLR, then HLR provides the authentication information to BSC and BSC then authenticates your call and you are getting the permission to communicate. Whereas once your data is received from your handset, that is your hardware information number as well as the target communication number as well as your own communication directory number to the BSC, it will send it to MSC. It will check your location where your number is and it will also check the location of the target mobile device, whether it is in the same cell or in other cell or whether present in the particular this NSS or in other NSS. If it is found in the same NSS, then it will send the information to BSC as well as it will ask the BSS of the target station to communicate with the target device. If it is not there, the target device is not there in the jurisdiction of the NSS, then it will send the information over the another MSCs, means all NSS are send the information about your target mobile requirement. And these other MSCs, they check their location register and HLR whether this device is present in their area or not. If a particular MSC finds that the target device is present in that area, then it sends the information to the calling MSC to verify that yes, this device is located in my jurisdiction. Once the device is found, the MSC will send the information to BTS and simultaneously the target BTS station to authenticate the communication and allow the channels to be used. Once this procedure is complete, then the respective base station of the target device is sending the instruction to the target device to ring. And once the ring is going to the target device, the channel will be switched from the communicating mobile device to base station and from base stations of the target device to the target mobile to the same base frequencies. And then the control will be hand over to the communication channel and the data will be allowed to transmit from the communicating mobile station to the other mobile handset, that is the target handset, over the data channels. This way the communication is handled. So whenever any mobile calls to any other mobile, then it will be first getting connected to its own BTS. BTS will communicate the information about this mobile and its communication requirement to MSC. MSC will validate that particular mobile device, validate its location, validates its equipment identity in the equipment identity register, authenticate the devices and communication and then send the information or find the target device in the same MSC or in another MSCs by communicating it to another MSCs or even other networks. Once the target device is located, the target will inform the calling MSC that the target is available. Then it will ask the target to switch the channels to same channel of the calling mobile station. And then these two mobile stations are getting connected by NSS and the mobile network stations and allowed for communicating bidirectional data transmission and voice transmission. This way, the mobile connection is established. Some of the questions asked in the university exam papers are listed here. The question on structure of mobile system shown. The question on GSM system and its architecture is shown. The short term question and answers expected and called in the university papers are shown here, and the long answers questions are also listed here. Whereas answer to all these questions are covered in the discussions we have done today. And therefore, you have to locate and identify the information and write accordingly under the particular question. That's all about the mobile communication, that is cellular communication. So today we will finish. Bye bye, friends.